All right, in this video, we're going to talk about polyatomic ions. Uh, so the thing is, you just have to start somewhere. And so first, just to kind of say is that polyatomic ions, what makes them special are that they're covalently bounded units, but instead of being molecules where they're neutral, they're ions. And then because of that covalent bond, what I say is that they're stronger than usual, and so they don't break apart. What will exchange are going to be those ionic bonds we form. And so at the end of the day, the list is quite large and you just have to start somewhere. So in my class, I kind of break it down into focus here, learn these, the common ones, and so on. Um, on this Kim Libre, I think one nice thing they do is they break it down by the charge. So learning 1 minus, 2 minus, 3 minus, 1 plus. All right. So which one's the easiest? 1 plus. All right. Ammonium. And I'll just highlight that this is really confusing because ammonia is NH3, a molecule neutral, and ammonium, we add a H plus ion to it, we get NH4 plus, and this is the only cation you have to know, all right? And then everything else would be an anion. And so what you need to know then is going to be the charge, the number of oxygens, because all these have oxygens. That's what they have in there. And some of them vary a little bit, but for the most part, that's the number of oxygens. So the charge and then the name. All right. And so we'll just kind of break it down into the easy deliverables and then you'll build onto it. So acetate, we can see it's quite confusing. We have the CH3, CO2, and so that's a hard one. So kind of skip on it and then kind of come back to it. First, focus on learning the phosphates. And so we can see dihydrogen phosphate. But if we scroll down to just phosphate, doesn't have it here. Oh, wait, 3 minus, that's why. So, so if we start here, then phosphate and learn this one, then so phosphorus with 4 oxygens, 3 minus charge, all right? And so then if we start adding hydrogen and we come back to this ammonium example, right? We start with NH3 and we add H plus, then this leads to NH4 plus, all right? A first reaction. So and this is going to actually be in equilibrium, kind of tricky, and we'll talk about this in the second semester. So it's a proton source. So that's how we go from NH3, a molecule, to the polyatomic ion. Yeah. So the thing is, as we add H plus, we add one H plus charge to it, and so we can see that if we add two H pluses to this, what do we get? We get H plus sorry, two H's, PO4, and now what's the charge? We'll have 3 minus plus 2 plus, and then what does that equal? 1 minus. And so we would predict a 1 minus charge. And so if we come over here, you can see that's it. So you can see if you start with these kind of key ones, and then you build up to the more complex, adding another H to it, then you really don't have to learn anything. So start with the 8, and now the ites then are the next transition. So 8s are the more common, and then you can look at the transition to the ite, and we can see there's one less oxygen there, and then the charge, you still gotta learn it. I don't know that it's really follows a trend here. There are some YouTube videos, I link it in my class, then for tricks to be able to find the charge on the polyatomics. To really do this, you need Lewis structures. I think that's the way I do it. You'll learn that later, so doesn't help you. All right, so start with the 8s. The 8s I recommend then are going to be, let me get my pen back. So phosphate, ammonium, and scrolling down, then we'll have hydroxide will be one for base. Come on, yeah. Zoom just be nuts. Nitrate, hydroxide, sulfate, and I think that's going to be it. So in my class, I'll list a little more, but that will give you a starting point, and then you can build off of it. All right, that's it.